So given matrix A, we need to express the inverse of A as product of elementary matrices, and we also need to express A as product of elementary matrices. So let's start by writing this down as matrix A 2 1 6 4 and identity matrix right here 0 1 0 1. And now we will do some row operations in order to express it as elementary matrices. So first, which we are doing, we substitute row 2 by row 2 minus, actually I'll write it here, we substitute row 2 by row 2 minus 3 times row 1. So we get 1 0 negative 3 1 times elementary matrix, and this equals 2 1 1 0 0 1 negative 3 1. Now we substitute row 1 with row 2 divided by 2, and we get 1 over 2 0 0 1 as elementary matrix 2. So here we get 1 over 2 0 1 1 over 2 0 negative 3 1. Now we substitute row 1 by row 1 minus row 2 divided by 2 times 1001. So row 1 minus row 2 over 2, this equals 1 0 negative 1 over 2 1 times elementary matrix 3, and this equals 1001 2 negative 1 over 2 negative 3 1. So we know that elementary matrix 3 is 3 times E2 times E1 times A equals identity matrix. So E3 times E2 times E1 times I equals A inversed. We can recheck it. So A inversed equals A3 times A2 times A1. So we will get A3 times A2 times A1. We will get 1 times negative 1 over 2 0 1 multiplied by 1 over 2 0 0 1 and multiplied by 1 0 negative 3 1. Again, let's recheck it. So this equals 1 negative 1 over 2 0 1 times 1 over 2 0 negative 3 1. This equals 1 over 2 plus 1 over 2 1 over 2 plus 3 over 2, and here we have 0 minus 1 over 2, so negative 1 over 2. Here we have negative 3 and 1, so this thing equals 2 negative 1 over 2 negative 3 and 1. So yeah, this is the elementary matrices product of which gives us A inversed. Now let's find A inversed, which is actually A. So A inversed equals A E3 times E2 times E1 inversed. So this, we get that A equals E3 inversed times E2 inverse times E1 inversed. In that case, if E1 equals 1 0 negative 3 1, that E1 inversed equals the determinant is 1, so it will be 1, 0, 3, 1. Then if E2 equals 1 over 2, 0, 0, 1, then the inverse of E2 equals, so the determinant is 1 over 2, so here we have 1 over 2, and here we have 0, 1, 0, 0, 1 over 2, and E3 equals 1, negative 1 over 2, 0, 1. So we get that the inverse of E3 equals, the determinant is 1, so it's 1 over 1, and here 1, 1 over 2, 0, 1. So that means that A equals, here 1 over 2 will give us 2, so it's 2 times this matrix times this matrix and times this matrix. Again, we can recheck it. And we will get that it's 2 times 1, 0, 3, 1 times 1, 1 over 2, 0, 1 over 2. This equals 2 times 1, 1 over 2, 3, and here we have 3 over 2 plus 1 over 2, which is 4 over 2, so it's 2, and this equals, now we multiply by 2 and we get 2, 1, 6, 4. So yeah, this works, and we have shown A as a product of elementary matrices, and we have showed A inverse as a product of elementary matrices.